the actuator mechanism, contacts, the terminals where we make the wire connections, thermomagnetic strip, and last but not least, the lever that we use to turn a circuit breaker on or off or reset it in case it trips. We now have too many appliances running on one outlet, which has created a situation where the current draw of the appliances exceeds the amperage rating of the circuit breaker. This overcurrent condition heats up the bimetallic element, changing its shape to the point where it releases the lever, trips the circuit breaker, and interrupts our circuit. Let's watch that again. Brenda, hit it.
I'm doing it now.
There's so much current passing through that strip, it creates a strong magnetic field that pulls that lever open almost instantly. I found it mind-boggling how fast this actually happens. And if we look at the image data, we can see that the entire event took a mere 6 milliseconds. What that means is they've combined two mechanisms in one, a thermal overload for gradual overcurrent situations and a magnetic device in situations that need to be interrupted immediately. Oh, I just almost touched that. Short circuit number 2. Here it goes. Well, there you go. And on circuit breakers, next time you have a circuit breaker trip, now you know what's happening inside.
A fuse is a thin metal wire that protects a device from too much current. Here's how it works. When electrons flow through a circuit, they create heat in the metal wires. The thinner the wire, the harder it is for the electrons to move, so more heat is generated. When there's too much current, the fuse acts like a weakest link in a chain by heating up more quickly than the other components, and it melts. That breaks the current flow and protects the more expensive components from damage by heat or fire.
If a motor draws too much current too quickly, the fuse will blow.
In a common relay system, you would push a button to energize a relay, which in turn will pass current through a set of contacts that close when it's energized. There are many common everyday items that use a relay to operate. We'll dive into those in a minute. But first, I want to talk about why you may need to use a relay system. A very common reason, especially in an industrial setting, is for voltage and current requirements. Many machines and equipment use a higher voltage to run. To make it safe for the operators, we use a low voltage and current for our controls. You wouldn't want someone pushing a button with high voltage attached to it. I know I wouldn't want to on a regular basis. It takes a very low amount of current to cause bodily harm. Plus, most push buttons and switches are rated for fairly low current. When we use a relay, the contacts that close can be rated for much higher current. Earlier, it was mentioned that relays are used in many everyday applications. One of those applications are the headlights on your car. When you turn the headlight switch to on, the wires are not connected straight to the light. The switch has a positive wire from the fuse box. It then has a wire from other terminal of the switch to a coil terminal on the relay. Once this coil circuit is closed with 12 volts, the electromagnet inside the relay is energized and a set of contacts will close. The input contact will have 12 volts connected to it. The output contact will have a wire connected from it to the headlights. Therefore, once the coil is energized on the relay via the light switch, voltage will pass from the input contact to the output contact and turn the lights on. In an industrial setting, relay systems are used regularly. One very common example is when an electric motor needs to be turned on and off. Commonly called contactors and motor starters, they are a prime example of a relay system. We use a low voltage, low current circuit for our motor controls. These can be push buttons or sensors that turn on the motor. In this case, we will use a photoelectric sensor to turn on a motor that runs a conveyor belt. Whenever a box is placed on the conveyor belt, the photoelectric sensor is blocked. The sensor acts as a switch that will send the low voltage to the coil of the motor starter. Once the coil is energized, the electromagnetism closes the contacts of the motor starter, allowing the high voltage to pass to the motor and run the conveyor belt. Once the box has passed the photoelectric sensor, it will turn off the motor starter by removing the low control voltage. Let's go back over this one more time. A relay is an electrical device that closes one circuit by being energized by another circuit. These can be used for many reasons. One that we covered today was for safety. When we use a relay to power a high voltage or high current device, while a lower voltage is used to power the controls that energize the relay. Relays are commonly controlled with switches, push buttons, and sensors.